All right, so last week we looked at the differences of p hats. This week we're looking at the differences of x bars. So we're taking two samples from two populations, measuring their mean, and comparing them by subtracting. So when it was the p hats, essentially we checked np, n1 minus p, greater than or equal to 10, and when it was a difference of p hats, we had to check for both samples. And it's essentially the exact same thing here, other than the rules for x bars to be normal, we have to use are different. So we either know that our population is normal, or we know that our sample size is large enough, rule of thumb, greater than or equal to 30. Okay? And the center of that sampling distribution is going to be mu1 minus mu2. It's going to be subtracting the means of the populations. And here we have the formula for the standard deviation also on your formula sheet. At this point, guys, like, you need your formula sheets, okay? Because we're gonna end up referring to your formula sheets quite a bit. And whenever you don't have it, just get up and go get one of the pink ones on the side. That's why they're over there for you, okay? All right, so I'm gonna let you guys go ahead and read this. And then we'll kind of so you can familiarize yourself with all the information. I missed my mouth. All right, so here we're taking two samples from two distinct populations. What are our populations in this particular case? The populations, so one is the boys, one is the girls, right? That's the distinction. And so we have the mean of the girls is 56.4 with a standard deviation of 2.7. The mean of the boys is 55.7 and 3.8. And we have 12 females and 8 males. Now, is anybody shocked to see that the mean height for the girls is taller than the mean height for the boys? Is that weird? Not at 10 years old. Do you guys remember that there's like a awkward phase where the girls have hit their like growth spurt before the boys? It was during a fire drill. It must have been 8th period, because I was walking out with Masha's class, and I teach downstairs 8th period. And Mrs. Masha was teaching middle schoolers, and the girls were all taller than me, and the boys came up to like here on me. It's always it's a fun grade level to observe because of how awkward everybody is, but okay. All right, so can we talk about first the X bars from just the girls? Will they be normally distributed? Yes, because the population is normal. And what about for the boys? Okay, so we can say the female and male populations are normal. So X bar F minus X bar M will also be normal. Approximately normal, of course. What is the mean of their differences going to be? I'm sorry? No. How'd you get 0.9? 56.4 minus 55.7? That's not 0.9. It's 0.7. The standard deviation? I have no idea. I can't tell from just looking at it. So we're going to go back and just look at, like, what we're doing is we're taking the females. We're going to do 2.7 squared over 12 and 3.8 squared over 8. I have no idea what this number is. Great. Okay. So what's the probability of getting a difference in sample means that is less than 0? Okay, so, and I'm pointing this out because I graded your homework last night, or this morning, the homework that you guys turned in on Monday, and there seems to be maybe a disconnect on some things, okay? So the mean of this distribution, we're going to do the 0.7, the standard deviation is 1.55, okay? And when we talk about, say, this point right here, in your guys' head right now, what does this point represent?
Someone who's less than 0.7.
Yeah. Yeah, and that's not what this is a graph of, okay? This is not a graph of us of people's height, okay?
Is it a sample that was less than?
It is not a sample that was less than.
A difference?
A difference in what?
Samples?
Between the mean of two samples. Do you guys see what I'm saying here? And I think it became very apparent in your homework, and when I pass it back, we can talk about it, okay? But we got to remember, like, when you draw a dot plot or a normal curve, we need to make sure we understand what is one dot on that graph representing. And this is saying I took a sample of females and a sample of males, and then I subtracted the means of the two. Is this okay? All right, so if I want to find the probability of getting a difference that is less than 0, I'm throwing a 0 on this graph. Shading to the left. I have no idea what the answer is.
0.326.
Now, let's talk about what this probability how we might interpret this probability. In particular, what does it mean to say that x bar from females minus x bar from males is less than 0? What would that mean?
The X bar of males was taller.
Yeah, this particular statement would mean that the male mean is bigger than the female mean. So is it possible we could gather these two samples and find just from our two samples that the mean height for the boys was actually taller in the sample than the mean height for the girls? Could that happen? And in fact, what is the probability that I gather two samples where the male's height is bigger than the female's height? Roughly a third. So would it be very surprising to find that sample even if girls are in fact taller than boys at the age of 10 years old? No, it wouldn't be that weird. It would happen 1 in 3 times. That's reasonably likely. Is everybody with me? So one of the things, while I'm not going to ask you to overtly state what this means, I need you guys to be able to look at this and say, it means the same thing as this. Everybody with me? Because that's an important idea. And I think that's one of the things that kind of got lost in the homework that you guys did last week. Do you guys know what I'm talking about? Okay. All right. So would it be a researcher went and grabbed those two samples and found that the boys that the girls' height was lower than the boys? Is that surprising? Okay, so Richards is back, and you can tell because he just started whistling.